This is CNIT 128, and I didn't have any demonstration last week because my technical stuff all failed. I've set it up differently this week, and I think it will work. So I'm going to try and demonstrate these two projects tonight. But first, we'll do the last chapter on attacking Android applications. So I should have that ready to go, and here we go. So we've already done parts 1 and 2, and now we're down to part 3, talking about other security features of Android. So storage and logging. If you view an Android operating system and you do ls-l, you will see these letters before the name of the file. This is standard Unix and Linux permissions. The first character tells you if it is a file or a directory, minus for file and D for directory. The next 3 characters are read, write, and execute permissions for the owner, then read, write, execute for members of the same group, and then read, write, execute for everybody else. So that series of 10 characters are the permissions on Android. And here you see the common default one where the owner can read and write, but not execute this file because it's not a program, it's just a document. And people in the same group can read it, but people outside that have no permission to read, write, or execute it. And this is a common permission structure. And this is why we say the data from one app is not readable by another app because they would be an other and they wouldn't be allowed to get in by default. However, root can get anywhere. So that's numeric. You can also turn this into numbers. If you take 3 bits at a time, if all these are 1, that's 7. If the first 2 are 1 and the next one is 0, that's 6, and so on. So 3 base 8 numbers will, they call this octal, it's a really old system. 3 numbers will numerically express these permissions. All right. And this is determined, by the way, in Android with a Unix technique called umask. I don't know why they have to be so confusing. Umask defines permissions by giving you the bits backwards. So the umask has 0077, and that's the 7 and 7. So these turn into zeros. This 0 turns into 1, so it's read, write, execute, and I forget what the first bit means. It's something special. So anyway, for some reason, umask is the bit flipped default permission. All right. And that's why default, the things you create, files and folders, like when you're installing an app by default, only the app can go in there, nobody else, not members of the same group, not others. Just checking for comments. Kaiser does their own thing. Yeah, I think it is just with United Health. That's right. Yep, good. Right, and yeah, there's something about Lockbit. I see some news about it, but yeah, I don't know about that one. All right. Anyway, yeah, Lockbit just got taken down, but then they've come back. I know there's a $15 million reward for the Lockbit managers if you can find them. So a file is only accessible if the file permissions allow you in and the folder permissions above it and all the other folder permissions above it. That's called traversal checking. So there are flaws. The Droid Wall application, which is I think a firewall for Android, it used the IP tables firewall, but it had a script running as root with 777 permissions, which means anybody can read, write, and edit it. So any app could change this script and it would then run with high privileges. This is fairly common for security products. Quite a few antivirus products have this flaw, that they have some kind of high privilege process that takes especially protected viruses and deletes them or moves them, and sometimes people are able to modify that and therefore escalate privileges. Encrypting files is of course a way to protect your secrets, but the problem is where do you put the key? Now the right way to do it is to use public key encryption and have the private key on your server, which is not on the phone. Or use a built-in place called the Android, in iOS it's called Keychain. Android has a similar one, a place to put secrets. I forget the exact name. There is something provided by the operating system that tries to give you a safe place to put things, but an enormous number of people don't do this. So they will just have source code with the key in it. So here they're going to encrypt a SQLite database with the password test123, and it's just right there in source code, which is no good because you can easily recover the source code for an Android app. This happens a lot of the time. So there's a tool called SQLite Cracker that will take all the strings in the app. here's how you do it. And then you just try to decrypt it using every word in the app as a dictionary. This is a fairly common technique. And so if they put the key anywhere in the source code, you'll get in. Another technique that's used for other kinds of encryption is to take a hard drive and just try every word on the hard drive to see if you can break into encrypted stuff. Now the SD card, I don't know how many phones still have this, but for a while these are actually physical cards you can move from phone to phone like a floppy disk. Now it's emulated on these emulators we're using. There's no physical card. But anyway, these things are like USB sticks, typically formatted with FAT, so no permissions are possible. And before version 4.4, Android required permissions to write but no permissions to read from it. So anything put on the card was available to every app. That was the plan. It was public information, and there were a lot of scandals. I think even Nessus made an Android app that stored secrets on the card. So it's a popular mistake to put secrets on the card.
I use SD card a lot.
What's that?
I use SD cards a lot.
Yeah? Oh, yeah, you do. Okay, yeah. Well, that's good. You have to move photos off the phone or something, right? Yeah, it's good for that, as long as you understand that there are no permissions and no security. Yeah.
The one thing bad about iPhone is when you put the picture, you have to get it through the mail.
That's right. You can't do it on the iPhone. That's what iCloud is.
Android, you can do this.
Right. Yeah, iCloud is supposed to be the alternative. All right. So anyway, WhatsApp put its database on the card, and anybody with this permission could read it. It was encrypted, however, but again, they used a static key that never changed. This is a fairly common mistake. People use private key encryption, and then they have a fixed private key, and when that key leaks out, then you're hosed. All right, so logging is useful for developers, and any application with read logs can read the logs. In Android 4 and later, they changed it, so no third-party app can retain this permission through normal installation, so that makes logs less accessible to third-party apps. I think you pretty much have to root the phone to get to them now. So one of the vulnerabilities we talk about is logging sensitive information, and you could argue perhaps that that is less serious now that this system has limited the scope. Anyway, you can enable a permission from ADB if you have root, of course, then you can grant that logging permission to any app you want to give it to. All right, and then there's insecure communications. We've talked about this. You can send unencrypted data over the internet, which is extremely dangerous, or you can send HTTPS but not validate the certificate, and we've tested for both of these. These are both very common flaws and quite serious. All right, so you can see here's HTTPS data being sent from GenieMD with a password in it, but it's not secure because it's accepting the fake certificate that comes from BERT. Now you can have, so here's the really low level security where you perform TLS but you don't verify the certificate, so that's bad. Now you have the normal level of security like your web browser uses where you can go to any website and it verifies the certificate with a trusted third party so you know who you're talking to, but you can have an even higher level of security with certificate pinning where the app will check the certificate, and not only does the certificate have to be verified by a trusted third party, but it will check another thing about the certificate, like it must have this key or must come from this particular certificate authority to verify that that certificate is the right certificate. That's called certificate pinning, and it is considered the most secure process where each app has an extra test beyond what a browser would have to make sure you're using the right certificate. And so if your app has that, then it's very difficult to get that app to talk to BERT. And there are ways to bypass it. You can ask at a custom CA to the trusted store, that might do it. That's what we did. You might be able to overwrite a package run with a custom cert. You can use Frida. We've talked about Frida, although Frida is so buggy and difficult to use, I took it out of the projects. It is very hard to get it working on a particular phone, and if students try to do it, many of them won't work. We may get back to it, but I haven't found a good, reliable way to use it. But Frida is an app you run on the phone with root privileges, and now what you do is you change the API calls. It's essentially a rootkit. This is what rootkits do to computers. You run a rootkit, and now when your apps make API calls, like to read a file or write a file, it Trojans that. It changes the function of those activities. So, for example, when you read files, because you're an antivirus app trying to scan all the files, it lies and it won't let you see certain files. So you can hide malware on the phone. And this is what Frida does. Frida lets you change the meaning of API calls, so when an app runs, it's now running in an altered environment. And so you can hook and bypass the certificate checks. You can take the calls to verify the certificate and just Trojan them to tell it the certificate is okay when it isn't. Or you can do the technique we'll do later in the project, where you just modify the app to remove the code that checks the certificate. These are all ways to do it.
I thought you can get certificates free now.
What's that?
You can get certificates free.
Yes, there are free valid certificates out there. Yes, you're right. But the problem with them is that if someone has already installed the app, an update using a different certificate will not be accepted. But yes, you certainly could get a free certificate and sign it with something that appeared to be the real company. It would probably fool people pretty well. All right, so often developers disable validation. I think this is just so they can test it before they have a valid server running. And I think they must be doing this for testing and then forgetting to remove it before they deploy the app. It's probably why this happens so much. Let's see what's happening here. Frida was driving me crazy. Yes, I got Frida working a few times, but I haven't found any way to make it work reliably enough for a class full of students all working on different machines to have any success with it. With certificate pinning, there are Frida scripts that seem to overwrite some generic pinning stuff. The most reliable method, exactly right. This is what we're going to do. The most reliable method is to read the code, find the certificate pinning, and modify the code and make a modified app that no longer checks. That's what we're going to do with the Indian ID card app. Good? All right. So web views is a browser you can put inside an app. Now, this is something people like to do because it makes your app pretty. You might have your app, like this is what happened to West Point and all the other, all the Straxis apps for many colleges. They would have an app for the college. It would then have pretty pictures of the college and things like schedules and administrators' phone numbers and stuff, and then it would have a link to like Twitter or Facebook. And when you clicked that, it would open inside the app. So you could now browse Facebook or Twitter inside the app, and I found that they all suffered from breaking TLS, and if you used that feature, it would expose your Google, Twitter, and Facebook password because the app wasn't as secure as the real browser on the phone. But this is a better experience. The users in the app, they want to tweet about the college, they view the college's Twitter file without leaving and going to another program, which would be more secure. So they do that with web views. Web views lets you put a web page inside your app, and that's an issue here. That's the problem. If your app breaks TLS, the web views inside your app also break TLS. I found this to be true of a lot of apps. And you can control this in something called the web settings class. So here you can say, set allow file access, allow from URLs and so on. There's settings you do to control it. And some of these control plugins like Flash and such. And here's the where you can let the web view save passwords. You can do that inside your app, and you can also override SSL verification. So it's an issue. If you're writing an app and you want to put a browser inside your app, you have taken on a very weighty responsibility. Browsers are very complicated, and it's very likely that you will not succeed in duplicating the security that really ought to be there for browsing the web. It would be a lot more secure when they click a link to just go open a real browser, but not as pretty an experience. Yeah, JADX is a very good friend. Yeah. JADX is the tool that takes your APK file and turns it into readable Java. And we're going to use it in the projects. That's the easy. Then you just read through the Java and find the part of the code that does things like SSL pinning. So now here's something important to understand. If you use HTTP, for a while people thought that was okay for things that are not secure, like they're not using passwords, they're just viewing like my home page. Why not use HTTP? The problem is you can send extra code with a man-in-the-middle attack like JavaScript. So it's not safe to use HTTP at all in any, because that code can all be altered on the way in. It is best to use HTTPS for everything. But you could add code and then have something like this, which will now refer to an internal file. It can be an image tag or an iframe tag. It will now run some kind of malicious app on the phone. All right. And there's JavaScript interfaces, which is even more disturbing and insane. This takes JavaScript within WebView and converts it to Java. So you can add JavaScript interface here, and then you can have a script here that's going to be going to call JS var hello. And so here is your Java code, which is going to print hello. And down here you have HTML, which is going to call this function, which is going to run the Java. So it's extremely powerful and extremely dangerous. This is like ActiveX in Microsoft Internet Explorer and other tools, something that lets you run powerful code inside the browser. And these things are often used for malicious purposes. And I was talking in the news this week, Microsoft Edge added a special feature called Super Secure Mode, which turned off the compiling to allow just-in-time compiled code to run, which makes it run slower but safer, and Chromium just added a similar feature to Chrome. So these things that run powerful code inside a browser are very dangerous. So here was add JavaScript interface arbitrary code execution. On Android before 4.1, you could execute any command because there was some kind of defect here on any device. It was inside the code. They executed something from a JavaScript interface. It went to Java and then executed a command that you could control. So that's arbitrary command execution. And there's a Drozer module to test for that. We're not using Drozer anymore, but it is a tool you can use. And all right, and there's other communication mechanisms that also might be insecure, like the network traffic. Let me just check for comments. I think I saw a new one. Yeah, the web view seems similar to an iframe tag. Yes, it is like that, but the point of web view is it's a whole browser that is in your app. That's what web views are. But you control all the settings of that browser, and you might not, as a developer of a Android app, the developer might not be careful enough to make sure they've chosen secure settings there. All right, so you might also use the clipboard and local sockets. The clipboard, of course, is the same it is in every other operating system. Unfortunately, this is typically how passwords get in. Your password manager takes the password, puts it in a clipboard, and pastes it into the app. Now, the problem is the clipboard is by definition readable by any app. That's the whole point of it. You're copying it from one app to paste it into another. So any app can steal it, and Drozer is the agent that can do it. And there are these things called local sockets. These are present on every operating system. You could start a listening port on an IP address, and then it would be a network socket. And you could make a network listening port on localhost, so it doesn't really go out the network card. But there's also something inside Unix called a local socket, where you can just listen on a pure Unix socket that is not tied to the network card at all. And you can send data from one app to another that way. So you can expect network traffic sent to the internet with Wireshark and Burp, things like that. But these local sockets, if you use these Unix sockets, I'm not sure how you sniff on that, but you can start something listening and things can be sent to it. Those sockets are memory objects. You can access them and send data to them without going to a network card. Right, and there are other vectors out there. Some apps have compiled code. They don't write everything in Java and run it in a Java virtual machine. They actually have compiled code. So then it's like Windows apps that are actually compiled down to machine code. The strings are gone, the labels are gone, so you analyze it with things like IDA, and that's what we're doing in CNIT 126. And it's much harder because you cannot get to the source code. The compiled Java apps can easily be reversed back to readable Java. These things cannot really be easily reversed back to readable C. So it's an issue, a thing to be aware of there. And the Android manifest may allow other things like application backups, so you can make a backup and get all the data. It may turn on debugging, and then you could turn on debugging if you allow USB debugging and observe the variables go by in the app. So those make an app much less secure. And okay, good. Yeah, spawning a whole browser. That's right, good, okay. All right, and so that's the debuggable flag. Now you can analyze the output of the app, and I haven't got a project where you do this, although I'd like to add one. I haven't written it yet, but there's an example here. ADB shell, you run this thing, sieve, and then you connect the debugging, and then you can do dump, and it will show you all the commands that sent data into the database. And so you'll see down here, it's putting in a Gmail with a name and then a hashed password. And so you get information on the way to the database that is not public because you used the debugger to log actions. All right, and so a certificate pinning we've talked about. So that's one technique where it will not accept the certificate from burp, even if you tell the operating system it's trusted, the app knows it's not the right certificate. Another one is root detection, which we're going to see. It does a test to see if the device is rooted and then refuses to run on rooted devices. This is fairly common, although really I think every bank app should have it, and I haven't found one that has it, but anyway, there's, all right, and then you can patch it. So we're going to do this in the projects. Here's one thing that will happen later in the projects. Here's code that detects rooting. It uses the root beer library. It's an open source library to detect if it's rooted, and this was the code, so all you have to do is comment out that code, and now it will no longer detect that it's rooted. Recompile the app and run the modified app. That's the technique we're going to use, which is very powerful. And by the way, this technique called repackaging, where you take an app, unpack it, modify it, and repack it to make a modified app, was not generally possible for iOS until this week. iOS, because of a European law, just turned on alternative app stores in Europe. So you would be able to put up a modified app, and perhaps in those stores. They're going to have some security controls of what goes in those alternative app stores, and we don't know what they are yet. But they forced them to do it instead of just having the main Apple App Store. They're going to have alternative stores in Europe only for right now. And that, so this problem of repackaged apps will probably increase in importance on iPhones in the near future. All right, and here's what I mentioned before with Frida. You can manipulate what they call the runtime. So you change the action of the operating system, so the same app that makes system calls, it has a different effect because you've modified the system underneath it. And that's manipulating the runtime. And you can do that with Frida or Cydia or the Exposed framework. Frida is the main tool people use. It's extremely powerful. So serious Android pen testers get a physical Android phone and they get Frida working on it. And this is very much like I've been talking to students in the projects. If you're a serious pen tester, you often keep your version of Kali or the tools you like work because Kali keeps breaking things. So again, it's very hard to do in general, but once you get it working, you'll keep that system working and then you can use Frida. So let's try a Kahoot. All right, I've got it here, 128, 7C. All right. All right. so what command will create those permissions? All right. Popular answer is correct. You read it in binary. This is 110. That's 6 because it's a 4 plus a 2 plus 0. And this is a 4. 4, no 2s and no 1s. So that's 644 is the octal numerical representation of that pattern of bits. All right. All right. So what data was widely available but then restricted to Google Apps only in Android 4.1? Those are the logs. The logs were available to every app. Now they're only available basically to root and Android apps, which makes your phone safer. Because a fairly common mistake is people log sensitive information. All right, so what's risky but often used by password managers? Clipboard. I don't know what else they could do though, because they have to move your password from the password manager into some other app that doesn't have like necessarily an API call or anything to send it in. So I really don't know what they can do but copy and paste it in. But there is some risk involved in doing that. All right, so what component might allow code execution by JavaScript? It is part of WebViews. WebViews, you can turn on these JavaScript interfaces, the bridge to Java. All right. One of the insecure features you might turn on in your WebView.